All right, y'all, good morning. So we're going to go ahead and begin. Um, I'm on my Sonic account right now, just so you know, because my Comcast internet is apparently down. So the reason I got the Sonic account is because I was afraid that might happen. So that way we have a backup plan. But the Sonic account's a little slower. It's probably maybe a third as fast. So I don't know if there'll be issues on your end, but let me know. Uh, just so you know. All right, people are going to probably be jumping in, and I'll just worry about that as we move on. So what we're going to do here is we're going to have expressions for the area and perimeter because what we're given has variables. So when we determine the area and the perimeter, what we're going to have is going to involve a variable. Now, the only way we'd be able to solve for these variables once we set the expressions for the area and the expression for the perimeter is we'd have to write an equation, just like we did yesterday, the equation where we determined the width because we knew the perimeter. And we used variables yesterday to model that problem, the rectangle. And then we could solve for the variable because we knew what the perimeter is, right? So creating an expression is not quite the same thing as determining the value of the area and the value of the perimeter, but it's creating a representation of the area and perimeter given the problem you're trying to work with. So all of these are going to have variables as part of the area expression and the perimeter expression. Okay. Now I can show you kind of where this stuff comes from. I may or may not do that today, but the circumference of a circle is the perimeter of a circle. So if you want to find the distance on the outside of a circle, right, just like if you measured the distance on the outside of your bicycle tire or your car tire, we call that the circumference. It's the perimeter of a circle. And if you're given the radius, you do 2 pi r. Whereas if you have the diameter, you do diameter times pi. And diameter is the whole distance through the center, so you got another radius over here. Okay? All right, so we'll look at these, but again, on the diameter, you got 2 radii. And the ratio of the circumference to the diameter is what we call pi. That's where pi comes from. That's what it is. For all circles, if you measure the circumference and you divide that by the diameter, you're going to get pi. And you can actually do this yourself, which if we were in live classroom, we do. You take a can, take a string, put the string around the can, right? And then measure that. That's the circumference. Measure the diameter, and you'll get pi. Now, of course, there's going to be a little estimation issue when you do the measuring, so it'll be close to pi depending on how accurate you are when you do your measuring. But that's where pi comes from. Okay, so if we go ahead and rearrange this formula by using cross multiplication, we get that. And since the diameter is 2 radiuses, we can change this into 2 pi r. Okay, so again, that's kind of where that comes from. I might show you where the area formula comes from later, but if not, just use the formula and don't worry about where it comes from right now. All right, so if we're going to get the area, for this shape, we already have the length and width. So to get the area, you're just going to go 2x times 10x. Now I'm using a dot to represent multiplication. Okay. So now when you multiply a bunch of stuff, you can rearrange the order in which you multiply. Now, you don't really have to do this, but I think some of us, we get a little goofy when we multiply. We think there's a distributive property. There's not. There's no plus here. So this is 20x squared, which if you understand how to get that from here, you might as well do that. Okay, so this is the expression for the area. And all we need now is the number for x, or know what area this is supposed to be and put that number equal to this and solve the problem. But again, we're just coming up with an expression. That's all we're doing right now. All right, now the perimeter. Well, the perimeter involves adding up all the sides. So remember, opposite sides of the rectangle are the same. So just like what we did yesterday, we added up all the sides. Okay, so you got 2x's, 2x's, 10x's, 10x's. So 10 plus 10 is 20. 2 plus 2 is 4. So the perimeter is going to be 24x. And what we did yesterday is we had an equation, and that equation came because we were told that the perimeter was 14. So we could actually find out the value of the variable. Okay, so here we're going to use the two formulas, the circumference and the area for the circle. And I'm writing them there because some of y'all, you're dripping in, a little later. So just in case it's easier, these are the formulas we're going to use. Okay, so the 2x represents the r. So we're going to replace this r with 2x to get the perimeter, which is called the circumference. That's why I'm using the letter C. Okay. Now again, the dot means multiplication. All right, so we got the 2 times 2. We got the pi, we got the x. Now, in general, it's a good habit to keep everything to the left of the variable. So I put the 4 pi to the left of the variable x. And again, pi is a symbol. It's not the same thing as a variable because pi only means one number. And the reason we use pi is because it's a number that goes on forever and has no pattern. So if we had to put a number instead of a symbol, we'd have to estimate. So rather than do that, we just leave it with a symbol so that if anybody wants to do a problem involving this, they get to decide how they estimate the pi. And on the calculators that we use, there's a pi button. So that's why we use the symbol. It's much more convenient. All right, now be careful here because for the area, we're going to square the radius. So the entire 2x is going to be squared. Again, we're using the radius expression given in the problem, which was 2x. Okay, so for the area here, I'm going to place the r in parentheses to make clear what we're squaring. All right, now if you don't do that, you might forget about the 2. You might think that's 2x squared. You might not square the 2 if you don't put in parentheses, because that 2 is also part of the radius. And that means 2x times 2x. Right? So we're actually going to get 4x squared. All right, so this equals 4 pi x squared. Now notice I'm keeping everything to the left of the variable. All right, I'll pause for about a minute. Now the next problem, we're going to have to decide how to break the composite shape into 2 rectangles. Now I'm saying rectangles, not squares, because we can't assume these two four-sided shapes are squares. We can't. That x may not be 5. Maybe it is, but we don't really know that for sure. So it's better to call them two rectangles for that reason. Now I decided to break it up this way. That way the dimensions of the two rectangles, one of them has a 2x and the other has an x. So I thought that would be easier. Now the smaller rectangle, at least it visually appears smaller, may not be, but we're just going to say it's smaller. We already know the dimensions, 5x. So we already have the area of the upper right rectangle. The bottom right rectangle, we have a width of 2x, but we're going to have to determine what the length, what the height is. All right. So we're going to have to use the opposite side of the rectangle. All right. So the opposite side of the 5 would be 5. And now we can see what the opposite side of the left rectangle would be. It would be 5 plus 3. So this is 8. Okay, so now we can get the area. Okay, so the area would be the 8 times 2x plus the 5 times x, which is going to become 16x plus 5x, which is 21x. So we had to interpret the dimensions a little bit for this one. Now, we still got to get the perimeter. And again, the perimeter is measuring only the sides on the outside, just like a fence. You know, if we wanted to fence off this composite area, say this was some property, we're only worried about the distance on the outside. All right, so we got most of them, but we're going to have to figure out on the top by using opposite sides. So opposite the 2x is also 2x, and opposite the x is also x. Okay, so now I'm going to let you finish that one on your own. So you only have one I'm going to make you do on your own. Now I've given you everything you need. So you're adding 8, 2x, 3, x, 5, x, and 2x. And that's going to be what you get for the perimeter.